Okay, good morning. So I would say that it is good if I give you a little bit of time to think about these problems, to review what we have studied so far. Of course, they might be a little bit harder than the level of the book, but I don't think you cannot solve these problems. Okay, so I will give you a little bit of time, then I will come back and solve it and try to see if there is any difficulties. And there is one part left in the topic of exponents, and that is the fractional exponents. So I want to talk about them. Yes?
Can you come here? I just want to, or should I come to you?
No, just let me finish. Okay, and then there is one part which is left, and I will try to complete this, and then we just start the algebra from the next session. Yes? So I will give you, I think 10 minutes is enough. So I will give you 10 minutes. If you need more, I will give you more. But for the time being, 10 minutes is okay. Okay, now let us discuss about these problems. Hopefully you could solve most parts of them. And then I will teach you the new part. If you have more time, I give you more time to practice. So, the first question, hello. Okay, so now I don't think you should face any serious problem for the first one. I don't think. Let me hear from you. What is the number that you got? Yes?
What was the question?
So what's the number you got at the end for this question?
The answer?
Yes.
9,275.
9,275. You? Okay, so that's a big difference. You?
Wait, we're on the first.
We're on the first, yeah. Any suggestions, Sergey? Yes?
275.
Okay, so we have two words for 275. It might be yes?
275.
Okay, good. So yes, probably it should be 275. So let us see why this is true. Let me, if you haven't got that far, so please listen to me again. If you have any questions, please let me know. If you don't ask questions, I will not be able to correct you. That's on you. So here, let me put this, for this one, a question mark. I want to answer this question mark. So, of course you realize that if you ask me, do you know this number? I would say no, I can roughly approximate this, but it's not good for this problem, because in this problem we are asked to give us the exact value. So this means that I should be able to write this expression in a way that I can use this piece of information instructively, yes? So what can I do? I hope that you have enough of these experience that 27 is a power of 3. You should be able to detect that immediately, yes? So I would write 3. Instead of 27, what can I write? 3 to the power of 3, and then to the power of x. This is what can I do? Here I have 4, and then this one, minus 4 times 3. Of course, here I can write it in two ways. Do you remember? I can write it as 3. Let me just write it here. So 3 to the power of 2x. If you write 3 to the power of 2 to the power of x, or if you write 3 to the power of x to the power of 2, both are true. But be careful, that's important skill that you need to develop in mathematics. Even if you ask me, is this true? I would say yes, and this is also true. But of course, for this problem, this is not useful, but this is useful. So this is what you need to learn. So here, why this is not useful? Because it gives me 9 to the x. And I do not have any information regarding 9 to the x in the problem. But if I write it in this form, then it is related to 3 to the x, which I already know what the answer is. So that is the point. Instead of 3 to the power of 2x, even if I can write both of them, one of them is useful, and I would write it as 3 to the x to the power of 2. Yes? And hopefully you still remember what we discovered yesterday, that we can interchange these two. Yes? And this is important here because 3 to the power of 3 is just 27. 27 to the power of x is not given in the problem. But if I just realize that I can interchange them, interchanging is useful here. Yes? I hope that everyone agrees with me now. So what I have done, this is also something that I use a lot. I will tell you that. I wrote the question mark in terms of 3 to the x. When I say this is usually I use a lot. It's in terms of. So it means that I have rewritten that expression in a way that 3 to the power of x is actually transparent. So you can see 3 to the power of x immediately. So I will say that this question mark is now rewritten in terms of 3 to the x. Why this is a good way to do? Because I already know 3 to the power of x is equal to 5, even if I don't know x itself. So then it becomes 3 multiplied. Instead of 3 to the power of x, I put 5, and then I have a power of 3, and then I have minus 4 times 5 to the power of 2. But then it becomes a very simple calculation. So, and then you shouldn't be doubtful about which one you have to do first. I have 5 to the power of 3, so first you have to do powers, and if you have a product over addition and subtraction, product has priority, yes? So here, what I have to do, if I want to continue this calculation, I need to do it patiently. If I want to calculate 3 times this number, first I need to know the number, what the number is. So I will copy and paste 3, I put a product here, but instead of 5 to the 3, I would write 5 times 5 times 5 in my head, which was, the answer is 125. And then I keep the minus sign for the time being, I keep 4 times, I have to do this one, which I already know is 25. And then it's very, very easy. Which one I have to do first? Because I want to subtract 2 numbers from each other, so I need to know this number, I need to know this number so that I can be able to subtract them. But this number is a product, so when I multiply it, it becomes 375 minus, I multiply these two, it becomes how much? 100. And as most of you told, actually, the answer is 275. And that would be the correct answer. Thank you very much for being able to solve this problem. Okay. The next problem is simple, but I have tried to somehow make it hard by putting negative signs somewhere else. Okay. So do you remember this? We also studied. Yes, there is a big difference between these two things. Yes. If I just write a to the power of m and then a pair of brackets around that and n to the power of n, we learned that this is equal to 8m times n. But we also talked about this symbol, which is usually not in the book, but they can ask questions. This is at the level of your knowledge. So sometimes we write it in this way. So you see AMN, AMN, but I have a pair of brackets here, the pair of brackets is absent here. So this is different. So here, what should I do? I have to calculate this one first, and whatever I get, I raise a to that power. And that is not equal to this expression in general. Sometimes it might be coincidentally the same, but in general they are not the same. Okay? So for example, yeah, I have enough space in front of it. So can I hear what is your answer, final answer for this, everyone? Just say it. 256, exactly. So it means that you understand exactly what is going. So here, what I have to do, if I give you this in the exam and I ask you to evaluate that, if you just write the answer, that's not acceptable. You need to do it step by step. Okay? So the first step that you need to do, you need to copy and paste these two that you see, because I need to know this package. And this you can do it in your head. You really don't need to write it 2 times 2 times 2. What's the answer? Is 8. So I put 8 here. And then here, of course, because I have asked you to determine the exact value, it means that you shouldn't leave it like this. You need to continue. And you can multiply 2 by itself 8 times. That's not a big deal. If you multiply it up to 5 times, it is 32. Another one, 64. Another one, 128. Another one, 256. So the answer is 256. But I want you to write this for me. Because if you write this for me, you are giving me this message that I know I have to start from here. Okay, so can I hear your answer for this one? This might be a little bit more tricky. Yes?
1 over 256.
Yes, 1 over 256. Yes, that's correct. Why? Because again, the same story. I have minus 2 to the power of 3. Is this minus influenced by this power?
Yeah.
Yes or no?
Yes.
Is this minus influenced by this power? No, because it is not in the pair of brackets. Of course, for the odd powers, it doesn't matter if you are careful or not. But be careful. If I want to put this minus sign under the power on this power, I have to put a pair of brackets around that. So if, of course, in this case the answers are the same. You see, if I give you minus 2 to the power of 3, it means minus 2 times 2 times 2, which is minus 8. Why? Because this part is 8 and you have a minus. But if I write minus 2 to the power of 3, this means minus 2 times minus 2 times minus 2. You see, the writing is different, but the answers are coincidentally the same. So be careful. Okay, but in this case, of course, it doesn't matter. So it means that I have to calculate this one first, but I have already done it. What is the answer? It is 2 to the power of 3 is 8. I have a negative sign here, it's minus 8. Then I have 2 here. That would be that I have to calculate. But there is also negative powers involved, and you know what to do. So you write 1 over 2 to the power of positive 8. But 2 to the power of positive 8 has already been calculated here. It's 256, and I have 1 on top of that. So this is what I expect you to write for me at the end. So 1 over 256. Understandable? Okay. Now let us go here. So what is the final answer to this number, everyone? Yeah, everyone.
1 over 60?
No.
16.
So be careful. You need to pay attention to what I say. Minus 2 to power 2 is how much? Minus 2 to power 2. So be careful about having a pair of brackets around or not. This means minus 2 times minus 2, which is positive 4. Yes, positive 4. So it means that here this becomes 2 to the power of positive 4, and that's a very simple question, which is 60. So the answer to this is 60. And now let me go to the next one. So what should I do here? Again, I copy and paste my base, which is this one, and I need to concentrate on calculating this part, which I have already done that, which is 8. But what does this mean? This means minus 2 multiplied by itself 8 times. 8 is an even number. So what do I get at the end? Positive or negative? Positive. So don't worry about this negative sign. Yes, so it means just 2 to power 8, which is, again, 256. So you see, there is no difference between this one and that one. They are exactly the same, even though they have been written in a different way. Okay, finally, let us go to the next one. So what should I do here? First of all, I copy and paste the base, which is minus 2, and then I calculate this 1. Okay, can you tell me just what is the final answer to the whole package? Minus 8. So I put minus 8. Then don't get confused that I have a minus sign here and a minus sign here. Just do it step by step. Which minus sign matters here first? The 1 in the power, in the exponent. So what should I do? I need to follow the rule. 1 over minus 2 to the power of positive 8. So you see, I didn't do anything with this negative so far. But we already did this. Minus 2 to power 8 means minus 2 multiplied by itself 8 times. Of course, if I am multiplying this negative number by itself even number of times, it becomes positive at the end. And then I have 2 to power 8, which is 256, but I have a 1 on top. So again, the answer to this one is also 100 to 1 over 256, which was the same answer as here. So be careful. These minus signs shouldn't confuse you. Is that understandable? Yes?
Do you want me to stop at 1 over 2?
Yes. Yes. Okay. Now, the other problem is probably a nice problem. I just want to see that how many of you could discover the pattern. Yes? Because here I am asking you to show that for every value of x, not just for a random. Some of you might choose a value for x and show that on the left hand side for that value is equal to the right hand side for that value. This is good. You are discovering something for yourself, but that's not the goal of this problem, because you cannot solve this problem case by case. How many cases I have to consider for every value of x means that how many cases are there if I want to consider infinitely many possibilities. And even supercomputers cannot consider infinitely many possibilities. Yes, they can consider only finitely many. So when I ask you show something for every value of x, I don't expect you to choose a number for x and show that this works for that number that you have chosen. You have to be able to argue that independent of my choice for x, this left-hand side is equal to the right-hand side. So it means that somehow you have to follow the rules that you have. Okay, but I want to hear from you which rule. So usually if I want to show that the left-hand side is equal to the right-hand side, I usually start from the side which is more involved and try to simplify it and reach to the one which is not that involved. So for example here, my preference is to start from the left-hand side and continue and reach to the right-hand side, because I see that the left-hand side is more involved than the right-hand side. So that is a rule of thumb, okay? Of course, you can also start from here and then go here, but you are making your life hard for yourself if you want to do it the other way around. Okay, so what I expect you to be able to explain to me is that let me just write here the left-hand side. Okay, if you don't mind, let me just write something more. Let me just copy and paste the left-hand side here. Dot means multiplication, and this. Okay, I want to hear from you what I want to write in front of this equality, and based on which rule you are saying that. If you want to tell something, first of all tell me what should I write, and then say why.
What you should write?
Yes, because I have to start following the rules so that I can show that by following the rules I can go from this to this. I have to show this. But this cannot be done in one step. You need to do it step by step. So what do you think? Can I write something in front of this one according to one of the rules that I have? Yes, Ali?
The 3x plus 1, we can simplify it.
Yes.
That means 3 to the power x times 3.
Yes,
3
yes, yes.
So you can.
But what is useful? Why this is useful?
Because you can use that to 2 to the power of 3, which is 8.
No, it's not 8. Be careful.
Yes.
Be careful. You see, because all of you were able to solve this exercise, so it means that you understood it quite well. But suddenly you mix it with the new idea there. 2 to the power of 3 to the power of x is not 8 to the power of x. This is wrong.
No, I didn't say that.
You said that? Okay,
8
might be.
to the power of 3x, I mean.
So here, as I understood, you told me that 3 to the power of x, I can write it as this. This, I agree with that.
Yeah.
Yes.
And I use that 3 on the right side to with 2.
Ah, you are still working here.
Oh yeah.
Ah, okay, okay. I thought that you said something for this one.
No.
Okay, okay. And then
I use that 3 with 2
to write it as 8.
Which is 2 times 2 times 2.
Yes.
And you can and you need to write 3x as well with the 2's.
Yes.
So it becomes 3 2 to the power of 3 to the power of x. 3 of them.
Yes.
And you can write a new exponent. Exponential.
Yes.
With,
Yes. This. So
four.
okay. At least this is very, very good because your understanding is correct. Okay. But let me make. So any other suggestions? So what Ali actually was telling us, working on this part. But I was thinking in a little bit different way. By the way, it doesn't mean that my way is better than yours or the other way around. If you are following the rules, and if I read and understand yours, you deserve the full points. And if I don't understand, then I will give you time to defend yourself. Then I will understand. Then I will give you the points. Okay? But usually I understand what you.
Was it correct or?
Pardon?
Was it correct?
Your ideas was correct.
Okay.
But I don't know, could you manage to reach to the right hand side finally or not?
Yeah.
Okay. I will come back to you, okay? But let me ask other opinions about that. Let me ask you something. I want to teach you. All of you can answer me. But you need to know, you need to value your math knowledge. So let me ask you in this way. 2 to some power, I don't know what is it in this box. Let us keep it a black box. 2 to some power. And I multiply it by 2 to another black box. So let me just circle. If I write something like this, you immediately detect the rule. What's the rule? Yes? Your name? Yes?
A to the power of m times a to the power of b equals a to the power of n plus n.
Yes, but that's the rule.
Yes.
Okay, in this context it becomes what?
To the square.
Whatever is inside this one plus
Plus
whatever inside this one. So you see, when I write it in this way, this is the take-home lesson. So when I write it in this way, you immediately recognize the pattern. But when I write it in that way, it is a little bit hard for you to detect the pattern. This is what I want you to learn to improve your skills. So you see, what is the difference? This is your black box, and this is your circle. Is that the same problem? So this is what I want you to improve your skills, to check, to immediately detect the patterns according to the laws that you have. Because I was completely sure, more or less, that all of you can answer this question in this way, but suddenly something happens in your brain that you cannot detect the same pattern when it is written in a little bit disguised form. Yes? This is really important skill that I want you to increase. Try. No teacher can teach you that. I can just pay your attention to this, you know. I can draw your attention to this point, but you yourself need to train your brain to use it over and over again. Yes? So you see, do you agree with me? All of you, I'm not sure that you can write this, but I don't know, for some reason when it comes here, you change your strategy. This is a deep point. Try to think about it and teach it yourself. I cannot teach that to you. I can just draw your attention to it. Okay, now can you tell me what can I write according to that rule now? So what can I write? Everyone?
2 to the power of
2 to the power of what is inside the box? Plus
plus.
what is inside the circle. Is that understandable? Yes, might be. Instead of this one, assume I have written this one, might be you still have a little bit hard time before this experience to write this. But hopefully you agree with me that this is equal to this one. If someone asks you, is this a valid equality? You would say yes, and if that person even go deeper and ask you why, you refer to this rule. You should be able to explain that. Yes? Yes?
What's the rule called?
There is no name. I don't have a particular name for that rule. So you can say multiplication of exponentials with the same power, with the same base. Yes? If I have 2 exponentials with the same base, and I want to multiply them, I write the base and I add the exponents. Yeah, that's the sentence behind that. So, is that understandable here or not? So far, this equality is valid for everyone? Understandable? Okay, now I want to continue. What is a little bit mysterious here? If I want to simplify this expression, I cannot do anything with 2. 2 already is simplified, yes? 2 is just 2, as simple as possible. But now, let me think about this part. And this part, so you see, I have trained my brain in this way. When I reach to this part, I have trained myself to ignore what is not necessary. Okay? So the hard part is just this part. So I just train myself to forget about what is not important, focus on what is the problem here. So the problem is to do something with that one. Is that understandable? And this, in principle, if you have done your homework so far, we had some of these problems before. And you succeeded and you quite understand. That's what I'm saying. If you cannot do it here, it's because of you don't pay attention to send it to your memory. And that is making mathematics harder and harder for you, because It's a really hierarchical subject. When I want to teach you B, in principle, you need to know A. If you have forgotten, then you don't have any problems with B itself. You don't understand it because you have forgotten what is A. So please try to train yourself. Okay, now I want to follow Ali's strategy here. So for these two, I don't do anything. But here, I will write it as 3 times 3 to the power of x, yes? And then I have another 3 to the power of x here. Understandable or not? Yes? Why? Because I am using the same rule in the other direction. So you see, copy and paste here, copy and paste here. Instead of this expression, am I allowed to write this? The answer is yes, because this package is exactly this one. And when two things in mathematics are equal, I can use them interchangeably. Yes? Is that understandable? So this is why I can also go here. But what is the benefit of that? You see, what is this expression? What can I write for this total expression here? It should be a matter of 1 second to answer. Yes?
18x.
This one? No? Yes?
9 to the power x?
No, just this one.
Just this one.
So this is the gap, because I taught this to you and all of you learned even for harder problems, but you are still facing the same problem here. This I don't know how to teach you. You need to find the way yourself. Yes?
Is it 4 times 3 to 4?
Yes. You see again the same trick. If I write you, I have 3 boxes, I add 1 box to it. What's the answer? 4 boxes. But I have the same question for you, you hesitate to answer. I have 3 of these boxes, I add 1 more box of it. Yes? So you need to expand the way that you look at the problem. Do you see? This is the problem. All of you know the answer to this, but why you cannot use this here, this you need to discover in your brain yourself and try to correct it. I can just draw your attention to it. Yes? Is that understandable? Okay, so what can I write in this one? I can write 2. What can I write? 4 times 3 to the power of x. Understandable for everyone? Yes or no?
Yes.
Okay. Now, of course, I have made a lot of progress. I will call it a lot of progress because on the left-hand side, I had 2 terms involved. But so far, I was able to do it, and I am left with 1 term involved. And everyone knows that 1 term is simpler than 2 terms, so it means I have progressed. Yes? Now, I want to finalize the problem, and then you need another rule to come in. So, it's not hard. You just compare. This is what you got so far. This is your goal. 3 to the power of x is good because I have it here, so let me not change it. But instead of 2 and 4, which are involved in this, I don't need them, but instead I need 16. It's not hard to think in this way. You can understand what to do. So everyone should see that. But I want to write it step by step to make sure that you really understand and write something. For example, in the exam, if you just write this is equal to that, I'm a little bit suspicious that if you really understand that or not. So how do you motivate your answer? What should I write here to be able to reach there? Anyone else? Yes, Eric is what?
No, Oscar.
Oscar, yes.
You can write that as in brackets 2 to the power of 4.
This is what I mean. 2 to the power of 4
Yes.
to the power of
3.
x. Of course, if you write this, that's okay. I don't need more explanations. But if I ask you more explanations for that, which rule you are using to write this?
That rule number like 5, I guess.
Forget about the names. So a to the power of?
What? A to the power of n in brackets to the power of m equals a to the power of n times m.
N. Okay. Are you in using this? Are you going in this direction or in this direction?
The other direction.
This one. Exactly. Going from this one because you have a product. You split it into 2 parts. Yes. So now, if I ask you what is another name for 2 to the power of 4, it's 16. And then instead of 2 to the power of 4, everyone can write 16. And what is left for me is 3 and then to the x. And what happened? I started from the left-hand side. I did everything in a legal way, mathematical, yes, and I reached to the right hand side, and then I am done. So you see, left hand side is equal to the right hand side. So it means that this equality is valid regardless of what value I choose for x. Is this kind of reasoning understandable? So this is very important. But what you said, actually, I used it here. Okay, so that's completely okay. So what you did, you start to do something here, and you wanted to do something here, and then combine them, you will reach to the same answer. That's correct. But I wanted to teach it in this way, because I wanted to show people know much more than they can do. So sometimes you know something, but you don't know that you know it. So because you don't use it. So this, I want you to teach yourself why you could not solve this problem if you could. Okay, now the last part of the lesson in the exponents is that, if you remember, we started with the natural powers only for writing products shorter. And then, of course, mathematicians always think, okay, what happens if I have other exponents? Okay, so we talked about negative exponents. And the natural question after that is that, what if I have a fraction exponent? Yes, for example, 2 to the power of 1 over 3. So what can I do with that? This is a little bit harder, okay? Not harder, but understanding might be a little bit harder. So I just want to try to explain that for you. So let me start the new lesson today. So there are some technical things. I don't know if you want to take notes or whatever. Of course, they are recorded. You can listen to this later. So there are some technical things that I want you to understand. Let me start with a simple case. First of all, if you have your calculator with you, or GeoGebra or whatever, if you put this number in calculator, you get a number. But the point is that how the calculator knows give you that number, or what that number even means in the first place. Okay, so 3 to the power, you see, I am working with fraction powers. So far, if you haven't studied this before, you don't know the answer. Okay, because I just told you what to do. If I tell you 3 to the power of 2, you know what to do. It is 3 times 3. If I tell you 3 to the power of minus 2, you again know what to do. You write 1 over 3 to the power of 2 and then calculate. Now I am asking similar question, but I have changed the exponent to a fraction. And I'm asking the same question. And of course, if you just type this in your calculator, you get a number. But that number, what is the meaning of that number? And this means that this number that is provided by the calculator is an approximate number that if you raise it to power 2, it becomes 3. Okay? So what you get on the display of the calculator is not the exact representation of this number. You cannot have the exact representation of this number because this number turns out to be irrational. And if a number is irrational, it means that the decimal points will never ever end. So even if I have a computer display the size of this room, I will not be able to give you the exact answer to this number because the number of decimal points will be infinitely many digits. Yes? So what you see on the display is not this number, but it is an approximation for this number. Okay? But how I can define this number? So what is this guy in mathematics? This is a little bit strange logic. We say that first we show that there is a unique positive number whose square is 3. But what that number is not our problem yet. I'm telling you, the proof of this is hard. It's beyond you need to go to pure mathematics to see that. Okay, but when we say that there is one unique, you need to trust me on that because of this statement. I will not be able to prove it for you in here. But there would be one exact exactly, there would be exactly one positive number, so that when I multiply it by itself, it becomes 3. Okay? This 3 to the power of 1 over 2 is the name for that mysterious number. So this is the only way that you need to think. Let me just repeat that. I am claiming, this claim cannot be shown here in detail, okay? But you need to trust me on that. I'm claiming that there is one positive real number, so that if I take that number and multiply it by itself, it becomes exactly 3. Yes? You might say, how I am sure about that? I am sure about that because I have studied a little bit more advanced mathematics. I have been convinced. And I cannot tell that to you because this needs more mathematical tools, but you need to trust me on that. Okay? The rest of it you can understand immediately. If you trust this part, then you see that that number, we need to show it with a symbol. That symbol that mathematicians use is this symbol. So if someone asks you what is the meaning of this symbol, you should say that this symbol refers to the unique positive number, so that if I multiply that number by itself, it becomes exactly equal to 3. Is that understandable? So now if I want to test your understanding, what is this? Yes, please. Yeah.
3.
Yes. Why? Because that's the definition of this symbol. This symbol means the number that if I multiply it by itself, it becomes 3. So now I am asking you, multiply it. What do you get? 3. Is that understandable? But there is a nice relation. Now you see, even if you don't know this mess that I discussed with you, you could solve it using the previous rules. So what you say that I have 2 exponents with the same base. What I need to do, I need to add the exponents. And then what happens? 1/2 plus 1/2 is 1. 3 to the 1 is 3. So you see, automatically you get the correct answer even if you don't know what you're doing. Because usually when I ask you to multiply, for example, if I ask you multiply 3 to the power of 2 by 3 to the power of 2, you write 3 to the power of 4. But if I ask you, do you know this number that you are multiplying by this number? You say, yes, I know what this number is. Yes, and I am multiplying them. But if I didn't define this for you in this way, you might like memorizing things. You just might be able to calculate this. But if I ask you what is the meaning of this number in the first place, you couldn't describe. But now you can describe. Let me ask you, is there any one of you want to describe 3 to the power of 1/2 for me? What is the meaning of this symbol? Someone else? No one in this side? Yes, Tim, you just...
Square root of 3?
No, not yet. You know more. We will come back to that. That's the square root of 3. But what is the meaning of this again? Yes?
It refers to the positive unique number, which when multiplied by itself becomes 3.
Very good. Very good. Because you really emphasize on the words unique positive number. Why we have to emphasize on them? Because there is 2 numbers that I multiply them, it becomes 3. If one of them is positive, definitely the other one is negative, yes? Because if I multiply 2 negative numbers, it turns out to be positive again. But mathematicians are using this symbol referring to the positive unique one, not the other one. Why? That's a convention. You could give this name to the negative one, but they have chosen to give this name to the positive one. Yes? These are really deep things. Thank you very much for emphasizing on those words. Okay, so this is the idea. Okay, now can you tell me, if I increase this, what do you think? Now you can guess, you can have some guess. What do you think this symbol will refer to? You have some ideas now, yes? Yes, Sergey?
It represents a unique positive number which, if multiplied by itself 3 times, would end up being 3.
3. So it is very natural coming. That's the meaning of this symbol. When you see this symbol, it means exactly this. So it means that this one, if I ask you what is the exact value of this, what's the answer?
3.
It's 3. Okay? By the way, do I have another symbol for this one now? Yes?
3 to the power of 1 over 3 to the power of 3.
To the power of 3, yes? Because what I am doing, I have a box, the same box, I am multiplying the box by itself 3 times. So another symbol for that is box to the 3, yes? So it means that I can define it in another way. I can say 3 to the power of 1/3 is the unique positive number so that when I raise it to power 3, it becomes 3. So it's better, yes? Instead of saying multiply it by itself 3 times, because we already know what's the meaning of multiplying by itself 3 times. So if someone asks you, let me just tell you this. So what happens if I have a to the power of 1 over n now? This one is the unique number so that when raised to the power of n, it becomes a. So that is the meaning of this symbol. Is that understandable? But there are some technicalities that I want to draw your attention to. Okay, what do you think about this? So do you remember I told you that trust me on one part of this. What was that part? So I told you that 3 to the power of 1 over 2 refers to the unique positive number so that when I raise it to power 2 it becomes 3. One part of this argument I ask you please trust me on that. Which part was that?
The explanation to why it is large.
No. You are right, but I just want to give me one word. Yes?
Why it's unique?
Yes, that's so. I didn't address that, but you're really right. I need to address uniqueness as well. But uniqueness is the word. Another word is no. Existence. Yes, there exists. This is the hard part. How on earth I know that there is such a number so that if I multiply it by itself, it becomes exactly 3 is not trivial. Is that understandable? I'm just claiming that there is a number so that if I multiply it by itself, it becomes 3 exactly. I'm just claiming it. How should I know that there is such a number? So this existence and uniqueness, as you referred, are the 2 important words in that theorem. Okay? But now let me draw your attention to this. So let me make it -3. So, in general, what would be the meaning of this symbol? Tell it to me, yes? Yes, Hafsha? Yeah?
Unique number multiplied by itself equals -2.
-2. But does such a number exist in the first place? No. So this symbol is meaningless.
No.
You understand that? Because this, in principle, if I want to follow the same way of reading this symbol, it means that this should be a unique number so that when I multiply it by itself, it becomes exactly equal to -3. But this is not possible at all. Yes? How is it possible that if I multiply 2 numbers, it becomes -3? It is not possible. Because even if I start with a negative number, when I multiply it by itself, which is also a negative number, the answer turns out to be positive. So every one of you knows that there is no such a number at all. Yes? So you can just test this idea. You put pair of brackets around that and put 1 over 2. Just punch this exactly in your calculator. Then you will get an error or undefined or something like that. Because you are referring to a number so that if I multiply it by itself, it becomes -3. Any number that you imagine, when multiplied by itself, it becomes at 0 or greater than 0. It is not possible to have a number so that when you multiply it by itself, it becomes negative. So you see, the existence part is very important. In the first case, I am just claiming, and I hope that you accept me, agree with me. Yes? But in this case, you immediately realize that this is not possible at all. let me ask you another question. This symbol is meaningless. What do you think about this symbol? Is this symbol meaningless?
No.
This symbol is meaningful. Yes. Why? What is the meaning of this symbol? It means, first of all, there is a number so that when I multiply it by itself, it becomes 3. I refer it with that one. I am multiplying that number, which I don't know what the value is, by a negative sign. If you want to know the value of this, of course, how calculator knows to give you that answer, it's a little bit more advanced mathematics, so you need to understand how the calculator will give you whatever the calculator gives you. But for the time being, you can have, of course, you can have approximation for that. Do you think this number is larger than 2 or smaller than 2, even if you don't know the exact value?
Smaller.
It should be smaller, because 2 multiplied by itself, it becomes 4, and 4 is already beyond 3. So this number definitely should be smaller than 2. Is this smaller than 1 or bigger than 1? Bigger than 1, because 1 multiplied by itself, it becomes 1, but I want to make it 3. So if I go to 2, I am going beyond this number. If I go to 1, I am going below this number. So this number, even if I don't know, this is a value between 1 and 2. And you can check it with your calculator. If you check it, I think the answer would be 1.73, etc., etc. And that's exactly a number between 1 and 2. So far, the only thing that you don't understand is why there is a guarantee such a number exists. Okay? Even uniqueness somehow you can understand. But let us put it aside. There are 2 things that you need to understand. Why such a number exists in the first place, and why this is unique. Okay? Of course, when I say positive, it becomes unique. Why? Let me ask you another question. What is the meaning of this symbol? It means, if I don't say the unique part, how many numbers there you expect? 2 numbers. Why? Because if there is a number so that when I multiply it by itself, it becomes 3, negative of that number have the same property. Yes? Is that understandable? So this is why in mathematics, for example, many people should probably have named Eric. Yes? This is human. But in mathematics, when you say the square root, we will see that this number should refer to exactly one thing. If that's not the case, then the poor calculator doesn't know to produce which one for you. So the reason that you punch this in your calculator, simultaneously punch this, all of you will get the same number. The reason is that calculator this is the name for one unique number. So this is why all of you get the same thing. If this refers to 2 different things, this is not mathematics. When you assign a notation for something, that something should be unique. Okay? It's not like the name in humans, yes? That name should be, that symbol, that name should be the name of one unique thing. In that case, you can name it this and give it a symbol for that. So these are very deep things, right? So just learn them, try to learn them. You don't need to worry about the exam. Okay, but now the good news is that we don't need to start everything from scratch again. Whatever we learned so far also works for this symbol. But this needs proof. Yes? So for example, what I am saying is that 3 to the power of 1 over 2 refers to the unique positive number so that when I multiply it by itself, it becomes 3. I take this number and I multiply it by 3 to the power of 1/3. This is the unique number so that when I multiply it by itself 3 times, it becomes 3. But now I am asking you multiply these 2 numbers. Can I say something about that? Yes?
You can say 3 and then you can use the rule that we learned before about adding this.
Yes, but there is a big question why. I want to skip that. Because again, the proof of that is beyond the scope of the lesson. But I want you to understand, technically, you have right to ask why. Do you understand what I mean? Because what I am trying to write in front of it, I want to write 3 to the power of 1/2 plus 1/3 using this rule, which I didn't invent it for this. I invented for natural numbers and negative numbers only. Whole numbers, not fractional. So you see, I want you to understand be careful. The reason that this still holds is because if you go to more advanced mathematics, you see that this again will work, but it needs a proof. I cannot just say that, okay, because this was true, accept this one from me. No. Is that understandable? Okay. So the good news is that after you understood what is the meaning of these symbols, you don't need to be worried about the rules. The rules are all the same. Is that understandable? Okay, so the rules are the same. And you learn something. You learn something that this has a little bit, you need to be a little bit careful because some of these symbols are not defined. So here, 3 to the power of 1 over 2 is defined. 3 to the power of 1 over 2 is defined. Minus 3 to the power of 1 over 2 not defined. Why it's not defined? Because there are no such a number so that when I multiply it by itself it becomes minus 3. So that's we say not defined. Or we can say it does not exist. Both of them are correct. Okay, but what do you think about this scenario? Okay, let me ask you, because this is very important. If I ask you just how many numbers are there so that when I multiply them by itself it becomes 3. How many numbers are there? 2 of them. One of them is, if you accept my claim, is the positive one, and the other one would be exactly that number with a negative sign. So there are 2. But there is a convention going on. If you start punching this in your calculator, you always get the positive number, even you do not get the negative one once. The reason is that there is a convention behind that. This is used for the positive one. Yes? Now let me ask you this question. Does this make sense? No, this one.
No.
It is not defined. It is not, does not exist. But let me change this symbol to this. 3 to the power of 1/5 and minus 3 to the power of 1/5. So what is the meaning of this? This is the unique positive number so that when I multiply it by itself 5 times it becomes 3. Do you think this is meaningful? Do you think this exists or not?
Yes.
This exists, yes, because here I have to multiply it by itself 5 times and 5 is odd. So if I choose the name, so what is the relation between them, by the way? Is there any relation between these two symbols? Yes?
Well, it's the same number, but one is negative and one is
Yeah,
positive.
exactly, thank you. So you see, you are discovering a lot of things just by definition. Is that understandable? Everyone understands that. So be careful. When you are dealing with this symbol, you have to be very careful about one point. Is the denominator even or odd? Yes? If the denominator is even, then this number should be positive. Otherwise, this doesn't make sense. If the denominator is even and this is negative, the whole package is not defined. Yes? And if I have this with odd denominator, both of them make sense. And then what is the relation between these two? One of them is negative of the other one. So this means that this minus can be pulled out from pair of brackets. So it doesn't matter if you put the pair of brackets or you remove it. For this case, they are the same. Yes? Understandable? Yes. So now, I don't want to repeat anything. So the rules are exactly the same. So the rules that we wrote for all the other exponents will also remain the same for this. Okay? And one more thing is this. One more thing. What happens? What is the next natural question?
What was the name of one?
Numerator.
What if the numerator is more than 1?
More than, or not equal to 1. That's a very natural question, yes? So I told you that I want to address fractional exponents. But this is not the whole story, do you agree? Because I have also a fraction like this. So what is the meaning of this symbol now? This I define it in this way. I would say that, do you agree that this makes sense? You would say yes, then I would say raise it to power 4. Okay, so this number to the power of 4 over 5 means this number that now you are familiar with raised to power 4. Is it consistent with the previous rules? Yes, because what was the previous rule? To multiply them. And if you multiply them, you get the same thing back. Is that understandable? So I have to address all of them. I have to address all possible fractions. This is also one possible fraction here. So how do we define this mathematical symbol? We say that first, go and find this number. Find a number so that if you multiply 5 times, it becomes exactly 3. It becomes a number. Whenever you found it, multiply it by itself 4 times. So that's the meaning of this symbol. Yes? I want you to understand the meanings. So if you don't understand the meanings, you still can solve the problems in the book. But I would say this is worthless because you are doing something without understanding. Okay? So if someone asks you, okay, you are calculating this, what you have calculated, you should say, I don't know what I have calculated, but I have calculated it. Okay? That's also one way, of course, doing things. Because many people doesn't understand what's going behind it. Of course, me as well. We don't know what's happening when I send an email. Probably a computer scientist can know what's happening in the diodes and voltages and things like that. But we are just doing it. So that's also not worthless. But if you want to understand it deeper, you need to be able to explain that. And especially when you are in technique program, I really want you to learn these things. Is that understandable? So the lesson today was give meaning to fraction powers. Okay? There was one gap that I couldn't convince you about the existence part and uniqueness part. Okay? But you need to trust me on that. Okay? But now everything becomes clear. Yes? Okay. Let me just continue this lesson a little bit more. There is also another type of numbers we are interested to put as exponents. I want you to know that. Might be there are not questions in the books at all. But let me just talk about that. So there is another type of questions. Can you tell me? Yes, please.
Decimals?
What?
Decimal, I don't know what it
The so there are, okay, you need to be careful about decimals because if I write 0.1, that's a decimal. But is it also a fraction or not?
Yes.
It's exactly equal to a fraction, which is. So that's a good question. So if I ask you what is this one, you can still understand what's the meaning. Because another name for 0.1 is 1 over 10. It means that that's a unique positive number so that when I multiply it by itself 10 times, it becomes exactly 3. So this type of decimals is not a problem. But are these decimals the whole story for decimals?
No.
There is a famous decimal, yes?
Do you mean like irrational numbers?
Irrational numbers. For example, the famous pi number is a decimal, so you have some part of it in your memory, 3.14. But 3.14 is not the whole story, just an approximation for that number pi. The decimals of pi will never ever end. Okay? It was not a simple question why this is the case, but the mathematicians were able to prove that. So don't worry. So it doesn't matter how fast computer you have, you cannot calculate all digitals because there are infinitely many. So that's also a decimal number, but it is different from this decimal because this decimal can be written as a fraction. Pi as a decimal cannot be written as a fraction. It can be approximated by a fraction. For example, 314 divided by 100 is how much? Is 3.14. But this is not pi. This is an approximation to the pi. So but the pi itself can never be written as a fraction. That's the meaning. So then what can I do? Do you think this is meaningful or meaningless? 3 to the pi. So it needs a new definition again. You understand? I cannot say that, okay, now that I told you this, you need to understand this one as well. No, they are different stories. Because that is not a decimal anymore. Okay? Another famous example of this number is called an irrational number. A number that cannot be written exactly as a fraction is called an irrational number. So pi is an irrational number. Can I ask why? Yes, you can ask, but you need to wait for the first year of university to see why pi is irrational. But another famous, very famous, handy actually irrational number is E is also more advanced than that one.
1/3.
No, 1/3 is a fraction. You yourself tell 1/3.
About 0. If you want to.
No.
write that as decimal.
Okay, but I understand. So that's another project. So I was a little bit careless. So you detected that. Yes. Sir. So yes, you are right. 1/3 is 0.3333 output. I didn't say that all decimals with infinitely many digits are irrational, but irrationals cannot be written as a fraction. So this means that this is not irrational, because we were able to write it as a fraction, even though there are infinitely many decimals. Okay? So if I want to tell you there are about this infinitive, so this is also one part of the lesson. They have omitted that one. So if I want to talk about these kinds of fractions, there are two fractions that repeat themselves. This one is called the simple one. We also have a mixed one. Mixed one means that I have one part which is not repeated, and one part which repeats itself. So this is also rational. This is also rational. The ones that end somewhere are also rational. The ones that have infinitely decimals without any nice pattern going on, that is irrational. So if I want to make it complete, that's the statement. For example, if I write 0.10101010 up to infinity, is this irrational or rational? This is rational, even though it goes to infinity, but there is a pattern going on. Okay, so you can understand what is coming next. But for example, if you look at the pi, of course this is very hard to prove, because I can have hundreds digits and then repeat themselves exactly the same after 100 times, you know. So this is why it's hard to say that this is a rational number. So, but let me summarize. If I have a fraction which ends if I have a decimal which ends somewhere, this is definitely rational. If I have a decimal which continues forever, but in a way that you can see one part is exactly repeating itself over and over, that is also rational. And even if you have a decimal point which one part is fixed and the other part will repeat itself. For example, 1, 2, 3 is the fixed part, and then suddenly I see 3, so let me write it like that. So you see these trees are going to infinity, they are repeating themselves, but one part is fixed. That is also rational. So these are only 3 types of rational numbers if you want to see them as decimals. This is why I'm always saying that work with fractions to avoid these confusions, yes? But it is also important to know. But for this pi, this will not happen. Okay, but now what was my question? My question is that how can I define this? This is a little bit more advanced. So what is the mean? We come to this conclusion. I ask you, give me another famous rational number, irrational number, except pi. And then you told me this. So that was the starting point. The famous irrational number. Very, very famous and handy. Yes, please? Square root of 2, thank you. So square root of 2 is a very, very famous and handy. For understanding why this is irrational, you have to wait for the university. For E, even a little bit longer. But for square root of 2, you have to see it in Math 5 in high school. So we can show in Math 5 why square root of 2 is irrational. Meaning, why square root of 2 cannot be written exactly as a fraction. You cannot find any fractions whose numerator and denominators are rational integers, and divide them, it becomes exactly square root of 2. But you need to wait why. But does this make sense? If you punch this in your calculator, again you get an answer. But what that answer is, this is very tricky. So you need to know a little bit more advanced mathematics to understand what is the meaning of 3 to the power of square root of 2. But if I want to give you a feeling, you can understand that. So I would say that 3 to the power of 1 you know. Yes? I would say that 3 to the power of 1.4 you know. Why do you know that? Because 1.4 is 14 divided by 10 is a fraction, and you already know what to do with fraction powers. And now if I go ask you what do you know about this one, you can tell me I know, because that's also the same story. If you put this square root of 2 in your calculator, these points, these numbers that I am choosing are the decimal points that your calculator shows. So this means that this and this and this you understand, and then we define this as the limit of this sequence. So this sequence goes forever because the digits will never end. So this list will continue forever. And there is a notion of limits for a sequence. We say that a sequence is converging to a point. That point is this number. So this is a little bit more advanced. So don't be disturbed, get disturbed with these things. But there is still a way to define them. But again, the good news is every rule that you apply for normal powers also work with this power. The only downside about this, you don't understand it in a full detail. So what is the meaning? So you need to work with it if necessary. But this would be the meaning that I try to describe it here for you. So this would be an infinite sequence. So for example, let me just tell you, you will understand what I mean. This is an infinite sequence. So do you agree? I can continue this list forever. What's coming next? 1/7, etc., etc. So what is happening? What do you think these values are getting close to one particular value when I increase these numbers? Intuitively, it is clear. When I start increasing these numbers, these values are getting closer and closer to a particular number. What that number is?
Zero.
Yes, Eric? 0. So this, in technical terms, we say this sequence converges to 0, or 0 is the limit of this sequence. Okay? So this is exactly the same thing. So I would say 3 to the power of a square root of 2 is the limit of this sequence. I just want to give you a flavor. But it was intuitively clear that they are getting closer to 0. But it is not very clear. Is there any number that they are getting close to? The answer is yes. That number is called this, which is a little bit convoluted. So don't worry about that. But I just want to give you a flavor. So now, more or less, all exponents are done. Yes, we started with the very simple idea of inventing a notation to make products in a compact way. And then we increase it to the negative integers, and then we increase that to the rational powers, and then we increased it a little bit to irrational numbers. But the good news behind all of them is one thing. All the rules that you have learned so far is valid for all type of exponents. Yes? Yes? Is that understandable for everyone? Okay. So let me now that you have a good understanding, I will never ask these questions in the exam, but I want you to understand them. Okay, I will just, don't worry about that. Okay, you don't need to be in a hurry. Yeah, most of the time I forget myself to close my phone. Okay, so I don't know what else I can say. Oh, okay. One more important thing. I know you are a little bit tired. But there is a little bit unfortunate. We have 2 symbols for that. I don't know, historically. So there is a more famous symbol for 3 to the power of 1/2, yes? A square root of 3. So a square root of 3 is a little bit unfortunate symbol that historically people were using. So we also use that. So let me tell you this. Unfortunately, if I ask you what is the meaning of this, there is only one unique number, positive number, so that if I multiply it by itself n times, it becomes this. But for that number, we can use this symbol, or we can use a more familiar probably symbol. So if you see this, unfortunately, yes, this is not good in mathematics. Usually, we need only one symbol for one thing. So why we should have 2 symbols for the same thing? Of course, for example, we have also 2 symbols for this. this one and this one are two symbols for the same quantity too. Yeah, so this sometimes happen. Yes, but this is just a mere symbol. Here, that's a consequence of the notion of division. We realize that what is this number is this one. But this is just introducing another symbol. And there is a way to read this. You need to read it the nth root of A. And there is a convention. If this n is 2, we don't write it. The reason is that the most popular one is the second root. So because this is so ubiquitous everywhere in mathematics, mathematicians are usually lazy. They don't bother to write that 2 up top and say that one convention once forever. If that's 2, we don't write it. Okay? So if you see this symbol, how do you read it? The second root or a square root. There are two ways of reading this in English. Either you just follow this, you say the second root of A, or you just say square root of A. Yes? And this means what? This means this, which we don't write. You don't see this symbol somewhere in the books. They usually use it. But you can write it as A to the power of? Half. Because n is 2. So if you see this symbol and that symbol, they are referring to the same thing. Yes?
If the numerator is more than 1, then the square root is to the power of that.
Yes. Why is that? Because, for example, if I assume that I want to write this 3 to the power of 4 over 5. Yes? This means 3 to the power of 1 over 5 to the power of 4. But for this one, we have that symbol. 5th root of 3, and then you have to the power of 4. You can write it in that way. Yes? Next time, because this square, by the way, another word, this is called radical sometimes. This symbol itself, and that is R. Actually, it was R, so then they have written it in this way. So still you can write it in this, some people write it now. So that is just an R for radical. And there is another English word for this symbol, and that's called a surd. Okay, so these are the words I want you to learn, okay? So I don't know if how do you call it in Swedish? This symbol itself. That's not the second root or whatever. I'm just telling you that this symbol is called a surd or a radical, okay? So I don't know how do you read it in Swedish, but there should be a word for that as well, yes? Anyway, so we also learned this symbol. What can we do? I can just give you an example, and then I think next time I will bring problems using this, and then might be, yes, we continue with exponents this week, and next week we will go to algebra. Okay? Because algebra, the beginning of the algebra, multiplying polynomials and things like that are heavily related to the powers, and the power is also a very important topic that you have to learn. So it doesn't mean that I will teach you a lot, but I will give you time to practice on your own, because there are many problems that you have to solve on yourself to learn. Okay, but let me see that what can I do here for you. I don't know, usually my examples are hard a little bit from the beginning, so I need to find a simple one for you. Okay, for example, what do you answer this question? Okay, so for example, so if I ask you to write something as, if I ask you to write this as one exponent, so what we should do? There are two exponents multiplied together. I ask you to write this as one exponent. How should I do that? Yes?
You keep the base and
Add the exponents, because I told you that the rules are the same, even though I didn't prove it for you. So this becomes this, and then nobody writes this like this and leave it, because there is a better name for that. If you cannot do it here, you can go to scratch paper, you calculate this. So what is the common denominator here? it's 6, 6. So this is 3 times, so it would be 3. That is 2 times, it would be 2. So it becomes, so the answer would be 2 to the power of 5 over 6. Okay? That's simple as that. What do you think about this? Of course, the downside about this is you are working with something that you don't know the meaning. You know, you have some idea about this sequence way of defining. At least some you can explain. You can explain that what is the meaning of this. I write an infinitely long sequence, and then I should convince myself that this sequence of numbers are getting close to one particular number. That number is this number. At least you have something to say. Yes, but you can calculate it exactly. How should I continue? Yes, please.
Isn't it 2 to the power of 3 times square root of 3?
Yes. Which rule you are using? So, because here, if I ask you what that number is, you say this number is an exponential. If I ask you what is the base is 2. If I ask you what is the exponent 2 times square root of 3. Yes? And then I am raising it to another square root of 3. So it means that I have an exponent and I want to exponentiate it once more. So what was the rule? Yes, the rule is a to the power of m times n. Yes? So what should I write here? It becomes 2 to the power of 2 square root of 3 times square root of 3. Of course, I will teach you later these things a little bit in more detail, but I think I can count on your Grundschule knowledge of mathematics. So square root of 3 times square root of 3 is how much? By the way, you can understand it. What is the meaning of a square root of 3? A square root of 3 is what? We define it today. Square root of 3 is?
A positive unique number.
Exactly.
By itself becomes 3.
Yeah, exactly. Very much. Thank you very much. So a square root of 3 is referring to that unique number, so that when I multiply it by itself, it becomes 3. Now I am multiplying it by itself. So what's the answer? 3. But I have a 2 here. 6. So it becomes 2 to the power of 6, which is 64. So this number is 64. Okay? So that is very interesting. So now you can calculate using these rules. I think even though we have 10 minutes left, but I think that this lesson was very long, so I talked a lot, so let me just finish the lesson here today. And I recommend you, when this video is finalized and I uploaded that, a little bit later, try to review that. I don't want you to sit down in front and review everything. You can fast forward, but try to send them to your long-term memory. Yes?
Or you can upload it the link.
Always I put the links. It means that you haven't seen the Google Classroom at all. Yes, I will always upload on YouTube and give you the link on the Google Classroom. Thank you very much. Bye-bye.